Welcome to Financial Math!
Today we're going to see the topics of
Independent and dependent
events,
conditional probability,
classic probability, counting problems. Let's start!
Now we are going to see dependent and independent events. Now, how to identify them? First, the independent events are the ones that are equal to their product. And the dependent events are the ones that are not equal to their product. Now, let's see some examples.
The probability that Jose eats an ice cream is 40%. And the probability that he drinks a coffee is 20%. And the probability that he takes both is 35%.
Now we have to convert the percentage into decimals, like 40% into 0.4, 20 into 0.2. Now we have to multiply those values, and that gives us 0.08. Now we transform the 35 from the both, and it's 0.35. Now we see that the result of the multiplication is different from the result of the both pastries Jose wants to eat. That means that this is an dependent event. The probability that you get a 3 in a dice is 1/6. This means that is 17.6%. And the probability that you throw a coin and you get head is a half, and that means 50%. And the probability that you get these two events is 18.5. Now we are going to denominate the dice event as A and the coin as B. Now we are going to transform the probabilities into decimals and do the same multiplication from the last example. And the answer for the multiplication is 0.085. And that is the same as the probability we get the both events. As we have the same result in both, that means that this is an independent event.
Hello, my name is Sergio Jimenez and I will explain you conditional probability. First, we need to know the conditional. What is a conditional probability? It's the probability of an event A occurring given that event B is occurring. Therefore, B is conditional. It's given by the formula P A over B. That means that the probability of A and probability of B down. Then the restricted sample space. This S with a little asterisk means that the sample space has been restricted, and it's given by this formula. It's the same but using different terms. N and instead of event B is S with an asterisk. Now an example. What is the probability that a random selected student in classroom 1305 plays a sport? Well, first in here we have a Venn diagram of the after-school activities that the total of 23 students play. We have that 8 play soccer, 2 play music, and 2 play soccer and music, and 3 play baseball, and 8 don't do anything. Now we have the formula is P A over B, having that A are people playing sports, which are 8 plus 2 plus 3. It gives us a total of 13, and B represent all the students in classroom 1305. Then we have that the conditional probability is 13 over 23.
Multiplication principle. When you multiply the number of events times the possible outcomes. We don't have a formula because, as you can see in the example is, for example, 3 6-sided dice are rolled. How many outcomes will we have? So the number of event 1, event 2, and event 3. The possibilities of us getting any number is 6. So 6 times 6 times 6 is 160. That's multiplication principle. Combination is almost like permutation, but here the order doesn't matter. This is a formula we can see it's very similar to permutation, but now we are going to add selected objects to the multiplication. So an example would be a pair of sneakers can be bought in 5 different stores. In how many ways can we select and visit 3 stores out of the 5? Since here the order doesn't matter of which store we go first, we use the formula, and here it's a small trick. 5 times 4 times 3 times 2 times 1. We can see that 3 times 2 times 1 is the same as 3 permutation, 3 factorial. So we just eliminate the 3 over the 3. And we had 5 times 4, which is 20, over 2 times 1, or factorial 2, which is 2, and the answer is 10. Permutation is an ordered arrangement of group of objects, so in this case the order does matter. This is a formula. R is the object selected and N is the total objects. So an example would be, in how many ways can 5 people be selected from a group of 8 if the order of selection matters? So the selected people would be 5 and the total number would be 8. We put it on the formula and the number or the result is 6,720. Now we're going to see factorials. A factorial of a non-negative integer n is a product of all the numbers between 1 and n. Basically, if we say factorial of 3 is a multiplication between 3 to 1, so it would be 6. If we say the factorial of 26, it would be 26 times 25 times 24 all the way to 1. And the product, it would be the result of a factorial, and this is the formula. An example of a factorial would be this one. A machine is composed of 5 parts that can be assembled in any order. If each order is to be tested once, how many tests should it be done? Since we cannot repeat the numbers, it would be 5 factorial, so 5 times 4 times 3 times 2, because it's the number of pieces, it would give us 120 possibilities.
Classic probability. Classic probability is the concept of an event to happen. The formula to get the classic probability is by dividing the number of times the event can happen over the number of possible events. P is the probability of event A. F is our frequency. N is the number of times that an event can happen. An example can be, when throwing a normal dice, what is the probability of obtaining a number that is less than 4? F would be 3, because the possible numbers less than 4 are 1, 2, and 3. N would be 6, because the normal dice have 6 sides. Now the result of 3 over 6 is 0.5. If we multiply this by 100, we will get a percentage. So 50% is our result. Another example can be, a bag contains 24 balls, 17 are blue and 7 are red. What is the probability of randomly selecting a blue one? Now, F would be 17 and N would be 24. And this gives us 0.708, and if we multiply it by 100, we'll get 70.8%.
Thank you!
Hope you learned something. Bye!
See you next time!